You know, right under the bustling streets of Minneapolis, there's a hidden danger, an old geological secret that has, on more than one occasion, literally swallowed cars whole. We're going to take a look at the city's soft underbelly and meet the geological detectives who are trying to map out this risk. And no, this isn't a scene from some old disaster movie. This is real life. Minneapolis, 1942. After a big storm, the street just gave way, and a car was almost completely consumed. It's this stark, black and white reminder that the ground we walk and drive on isn't always as solid as we think. And believe me, this was not a one-time thing. So now, scientists have this pretty technical-sounding name for it. They call it an emerging Anthropocene geohazard. Okay, what does that mean? Well, it's just a way of saying that this is a geological problem that we, as humans, are actually making worse, which plants it firmly in our modern era. So that's the big question, isn't it? What is actually causing the ground to just give way in a city like Minneapolis? Is this just some weird thing from the past, or could it actually happen again? And when you look at the evidence, you see a pretty clear pattern. I mean, look at this. A crumpled streetcar line from around 1952. Another massive hole in a downtown street from 1937. These old photos, they're telling a story about a city with this persistent, hidden weakness that just keeps popping up. To really get why this happens, we have to go underground. We need to meet the main suspect in our geological whodunit, the city's very unique and surprisingly fragile foundation. And the culprit's name is St. Peter Sandstone. Now, the two most important words there are weakly cemented. Don't picture a solid chunk of rock. It's more like sand that's just kind of loosely packed together, which means water can wash it away really, really easily. This diagram here really lays out the whole process. So water seeps down into that soft sandstone layer and just starts washing the sand away, carving out an empty space, a void. Eventually, the harder layer of rock and soil on top of it, that's the Platteville Formation, is left hanging there with no support. It just can't hold its own weight, so it fractures, collapses, and boom, a sinkhole opens up on the surface. This is the city's unique vulnerability. Now, it's really important to get this. This is not the kind of sinkhole you hear about in Florida. That's a totally different process. In Florida, you have acidic groundwater that slowly, chemically dissolves solid limestone over thousands of years. In Minneapolis, it's way more direct. It's a physical process. The water acts like a power washer, just blasting away and carrying off loose sand. And as you can imagine, that can happen much, much faster. So knowing the cause is one thing, but how in the world do you find these hidden voids before they collapse? Well, this is where the real detective work begins, as researchers start hunting for clues buried deep in the city's history and its geology. The researchers had this kind of four-part investigation plan. First, they looked at the known geology. Then, they dug into old records from well drilling, looking for any notes about unstable rock. They followed up on sinkhole reports from everyday citizens. And finally, they dove deep into the city's archives to look at old sewer construction records. And guess what? It was that last step that led to the big eureka moment. The best clues didn't come from some fancy modern sensor, but from dusty old paper records from city engineers who were digging the first sewer tunnels over 100 years ago. And it makes perfect sense, right? Those engineers were physically down there in the tunnels, seeing the geology firsthand in a way no machine ever could. As they were digging, these engineers were taking incredibly detailed notes about the rock conditions right on their construction maps. And here's my favorite little detail. The official report even says that some of these century-old technical maps were, quote, illustrated with beautiful watercolors. I mean, how cool is that? An unexpectedly artistic key to unlocking a very modern hazard. So, by putting all those clues together, the geology, the historical records, and those beautiful old maps, researchers were finally able to build something incredibly valuable, a hazard map that pinpoints the city's most vulnerable hotspots. And here it is. This is the payoff. This map not only shows where collapses have already happened, but it combines all that data to highlight where the conditions are just right for future problems. Suddenly, this abstract threat becomes very real and very local. And the research names names, pointing to specific zones. There's an area along the West River Parkway, parts of northeast Minneapolis near Dickman Park, and also places that are sitting on top of what are called buried bedrock valleys. Just think of those as ancient channels carved out by glaciers that got filled in over time, which can bring that weak sandstone layer a lot closer to the surface. But this whole story isn't just about ancient geology.
There are modern factors at play that are making this hidden problem much more urgent. This is where the city's foundation, its aging infrastructure, and our changing climate all start to collide.
And just to understand the potential scale of what could happen, think about this number, 300 feet. That was the diameter of the sinkhole when Chutes Cave collapsed back in 1880. It's the biggest in Minnesota's history and a pretty powerful reminder of what we're talking about here. So here's the modern connection. As climate change brings more intense, heavy rainfall, it puts a ton of pressure on the city's aging storm drains. That pressure can actually force water out through cracks in the old pipes, basically jetting it directly into that soft St. Peter sandstone. This speeds up the whole erosion process dramatically, turning a slow geological process into a much more immediate threat. It all leads to this final, pretty sobering thought. Okay, the sandstone under Minneapolis is unique, but that combination of aging infrastructure and a changing climate, that's not unique at all. It leaves us with a really critical question. What other hidden dangers are we living on top of? And will we find them before they find us?